Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. This is a partial fraction decomposition problem, as you can see from the notepad there, and notes next to the simulator. What makes it a partial fraction problem is that you can factor the denominator excuse me, and then the denominator when you factor the denominator, decides how you set up the partial fractions, etc. So let's see what we can do here with my programs. Index 8 to get to my menu here. You buy my programs, of course, and then you downloaded all the programs and instructions and everything, and tells you how to put the index 8 into here to get going, and you press enter, and you have a menu comes up, many things in this menu, but in this one you come all the way down to partial fractions in the P section, because I'm already here to save some time in the video. Partial fractions, there it is there. And we're going to enter the problem here. I've already entered it so that I don't mess up with the simulators. But for you, when you buy my programs and you start doing this stuff, you're going to find out that you need to press the alpha button first here, and then you can enter the left parentheses and the 8 and do all the entrance of it. 8 times x cubed it's set. Now when you see here, it's loading the program, but I've already entered all this into there, so to save time with the video. So here's 8x cubed plus 7x minus 12. We say it's okay. I always give you a chance to change it if you wanted to change it or made a mistake in entering it from your calculator. We factor the denominator. You write all this down in your paper here. We set up the problem by multiplying the left. I give you all the instructions of what I'm doing here, but not a lot of it, but just enough to get you make some sense of what you're doing. On the left side of the problem, you're trying to isolate these and eliminate the denominators here in the problem. But I'll show you how to do that. So I is integrate equals 8x cubed plus 7x minus 12 times the denominator here, and then you're dividing by the denominator. Okay, so in math and algebra, you can do the same thing on one side as you do the other, okay? So you don't screw up the equality of the problem. And then we set up the partial fractions on the other side. Multiply that times the factored the denominator. Factor the denominator, and we're eliminating the denominators here. So we have x squared plus 4. The quantity squared times ax plus b, x squared plus 4, plus cx plus d over x squared plus 4 squared. When you do these factors here, if there's a square here, you have to put a plus b, okay? If there's a square here, you have to put plus d. Otherwise you wouldn't. You'd just put ax, okay, or cx. So we eliminate the denominators. We're eliminating the denominator, the cx plus d over the x squared plus 4, or quantity squared, times this, which gives you cx plus d. So the original problem here looks like this: ax plus b times x squared plus 4 plus cx plus d. notice the nonsense of these kind of problems. These are really not trick, but they're puzzles. A million puzzles. That's what calculus is. You know, it should only be taught to math majors, should not be taught to engineers like us or potential engineers like yourself, okay? But anyways, write this on your paper if you're doing your homework or whatever you're doing. It would never be on a test. It's just too complicated for being on a test. But I thought I'd program it. Once I got into these factoring the denominator, I have to change all these. And you'll notice on other ones that my videos that I've changed, you know, put an x squared in here plus 7x minus 12. Take out the minus 12. Put x cubed plus x squared plus 7x, you know, and change this up in the numerator, and then do all the variables for that. We're combining like terms. And then we find out the coefficients of the other side. Here's the coefficients: 8, 7, and minus 12. Okay, we have to do them with the partial fractions that we've just figured out. For instance, 7x is equal to 4a plus cx. X is eliminated because they're on both sides, so you have 7 equals 4a plus c. We sub in a, which is 8. And we come up with c is equal to minus 25, etc., etc. And we're finding d the same way. Minus 12 is equal to 4b plus d. We sub in for b, which is 0. That eliminates that, so d is equal to minus 12. So we found out all the coefficients that go with the partial fractions. So here's the original partial fractions that we've made, you know, discovered. We sub in the values. And then we set up the integrals. We're going to integrate 3 integrals in this one, because 1, 2, 3, we don't have a x squared in here, otherwise there'd be 4 integrals. First integral is 8x divided by x squared plus 4 dx, etc. It's going to take too much time to go through each one of these, but anyways, let's continue on here a little bit and see if we can eliminate some of the talking. And we're going to integrate. That turns out to be for the first partial fraction, 8x cubed, turns out to be 4 times log of x squared plus 4 plus c. And we're going to do the second integral, which is minus 25x over x squared plus 4 dx. Imagine somebody who had discovered this and figured it out, you know. Taking the constant out of the integral. We always do that when we integrate. We take the constant out of the integration, you know. And of course, this is u substitution, because you can make here's x dx, and we have x dx in the original integral, so we can eliminate that by changing it to du divided by 2. Which we do. We substitute here. Here's the x dx right here, and then of course we have to divide by 2, which we're doing right here, to eliminate that. We come up with 4 times the integral of 1 over u squared du, and we integrate that, which turns out to be what you see on the screen here. We back sub u, and the answer is 25 over 2 divided by x squared plus 4 plus c. So now we're doing the third integral. I'm just going to go through this quick because it's such nonsense but it's all true, of course. It took me probably 2 weeks to program this like this. But with COVID, there was plenty of time staying home, huh? And there's a formula for that, etc. Substitute the values in there, simplify more and more. Now we have to integrate the integral that's involved with the formula. We do that. And so the reduction formula problem answer for I equals minus 12 times 1 over x squared plus etc. quantity squared dx is this right here, minus 3 halves. You can check this on your calculator, it'll come up with the same thing. And so the answer of the whole problem is this right here. Okay. So then we go back to the new, if you want a new problem, you can go back in to partial fraction, or you can go back to the main menu, or you can quit. Sorry this is so complicated, but that was, think of if you tried to study it and try to have a test on it, what that would be, you know. Go to my site, buy my programs, and pass calculus is as simple as that. Well worth the money, that's for sure. Everything's in your, and the physics programs are great too. Everything's in your Titanium Calculator. I don't even know if you're using those anymore in college, but you have to decide that. So anyways, good luck in your classes. You can call me if you download my programs. You can call me about calculus. I'll tell you how to do these problems, or whatever you have trouble with. Do everything I can to make you pass calculus, okay? So have a good one, and good luck on your classes.